Hey guys, in this video, I want to do a polar or just go over the elements for polar. And we haven't had too many here. And so what I did is I printed out these polar questions. You know what, and I forgot this one from 2018, but it's okay. I just kind of wanted to take a look at it because look at this, all in the last 4 years, you've had parametric. I mean, I don't know. Are they going to have another one here? I have no idea. I mean, have they ever done 5 in a row? Well, let's see. 4 in a row here, rate accumulation, and then they switched it. You see that? Let's see here. Well, this is 4 in a row, but then they COVID year. 3 in a row, and then they switched it. Except for Taylor's. I mean, Taylor, McLaurin, you're going to definitely see that one. I'm going to try to make a video for that one as well, but let's go ahead and just take a look at the polar just in case they throw that in for you guys. And what I did, guys, is I went back to 2019. Now I want you to see the type of questions they asked. So first question, find the area in 2019. Okay, find the area of this guy. Second question, what is the average distance? So that's an average value. All right. Letter C is a little bit different. They say this is the positive slope. Actually, you know what? Let's do that one last. Let me go back, and I want to show it to you guys. And let's see here. So 2013, let's start off with that one. In 2013, it says find the area. And letter B says find the coordinate of the particle's position. Okay, position. Part C, find the position vector, find the velocity vector. Okay. And then 2014, question 1, find the area. Okay. Question 2, find a rate of change here of dx d theta. Okay. And then it says find the rate at which the distance of the two curves is changing with respect to theta. And then part D, find the value of dr dt. So all rate of change. Interesting. But look at part 1 is what area? 2017, question 1, find the area. Part B, they gave you a ray that divided the regions into equal area. Okay. It says write but do not solve, and whose solution gives the value of k. Okay. Letter C, average value again. Interesting. Part D, find if w theta is increasing or decreasing at that value of theta. Okay. And then 2019 is the last time that they gave you guys a polar. And guess what? Question 1, find the area. Question 2, find what's the average distance from the origin. Okay. Oh, so that's average value again. And part C, this one's different because it says there's a positive slope m, divides the region S into 2 equal areas. It says write but do not solve. Okay. And then you want to solve for that value of m. And then letter D, that one's a little bit different. They threw in a limit there. Okay. So what can we see? Well, the first question is going to be area. They might ask you rate of change and increasing, decreasing, position. Man, it's just so hard to tell what they're gonna ask or how they're gonna ask it. But what I'm noticing is area, average value. Okay, so be ready for that. And then rate of change, at least that. Okay, guys. So just to give you an idea of what to fine tune your focus. So let's go ahead and do the first one. Find the area of S. And I just did it all quick, guys. I know you guys are studying and you're cramming, and I just want to kind of fine tune your focus. Kind of as you study, okay, what are the things that you want to fine tune and pick up on? You don't want to study the whole thing, okay? Make sure you know how to find the area. So in this case, you got the region S, and they give you r of theta, right? From 0 to square root of theta. Find the area. Area is just the integral, you guys know. 1/2 integral from a to b of r squared d theta. That's your function. And this is a calculated question, so it looks like question 2 has been the polar. It's kind of hard to make have them make you do a polar by hand, and it looks like they've been avoiding that, so might be a good thing. Okay, all right, so I'm not going to insult your intelligence. I think you guys know how to plug it into your calculator. You guys are BC students, and just plug it in and you should get 3.3534 truncated. I like to truncate it, just makes it easy, and that's it. And I think that question's worth 2 points. All right, letter B, it says, what is the average distance, okay, from the origin to the point on the polar curve? Okay, so average distance, think about your average value. Okay, average value is 1 over b minus a, integral from a to b of f of x dx. You know the drill. And it says from 0 to square root of pi, so 0 to square root of pi, and then you have your function r theta d theta. There it is. Now, if you get these two, I think this is worth 4 points, if I'm not mistaken. Yeah, if you get the first two, guys, that's 4 points already, which you're on your way to, gosh, you're on your way to at least a 3. What you don't want to do is leave anything blank, okay? Now, part C, that was a challenging part. It says there's a line with a positive slope m that divides the region into 2 equal areas. So right here you have a line here, right? That positive slope right through here somehow. And it says, now the good thing here is dealing with area, and that's what I've noticed. Okay, they're dealing with area here. So it says, right, but do not solve the equation involving one or more integrals whose solution gives the value of m. Now you got to start thinking, okay, what is positive slope? Well, how do I find slope, right? Well, slope is value of m, which is y over x, right? Rise over run. Well, because we're talking about a polar curve, how do we find that? How do we represent that? Well, that's a tangent. Okay, that's tangent of theta. So what they want us to do, because we have to find, right, from what intervals, right, limit of integration. So we're going to use tangent inverse of this value of m. Okay, so tangent theta equals the slope. So because we're dealing with area, it's just 1/2 the integral from a to b of r theta squared d theta. All right, that's the first half. We're going to set it equal, the other half, okay, the other half is equal to half of the area that we found in part 1, right here. And that's it. So this is my first half, and this is my second half, okay? And that's pretty much all that you need to do. Hopefully that makes sense. The hardest part, I think, is understanding, how to find that slope. If you got to think, okay, what is slope? Well, that's the m value. Well, it's y over x. Well, we're talking about a polar curve, so we need that angle, tangent theta. Tangent theta is the slope. And then to find that angle, we do the inverse, and hopefully you're able to, set it up. And then part D is the hardest part. It says for any k value that's greater than 0, a of k is the area, again area, of the portion of region S that's also inside a circle. So you got to think about your polar. Okay, what does this become? Okay, find the limit as k approaches infinity. So you got to ask yourself, okay, what happens as k becomes bigger? If I have my k value here and it becomes bigger, remember this is a circle, and it gets bigger, you're gonna have a circle right there on the x-axis, expanding, getting bigger. It's growing right there on that first quadrant. All right, so what you're gonna do, okay, it says it's in the portion of region S. So region S is right here. So it's all gonna be in this first quadrant. All right, so you're gonna go from 0, right, because the circle is getting bigger over here, from 0 to pi over 2. So you're gonna write the limit as k approaches infinity of a of k, and because we're doing area again of that function, is going to be 1/2 from 0 to pi over 2 of r theta squared d theta. And I guess if you want to go ahead and substitute the function, you can go ahead and do so, and you can go ahead and find the limit. Now go ahead and plug it into your calculator, and let me see here, you should get, I think it's 3.324, something like that, truncated. And that's it. that is it, guys. But again, I mean, it's kind of hard to say what they're going to specifically ask. For me, I think they're going to throw in a polar just because 4 in a row is going to be hard. I mean, look at that. Look at that. I mean, they've done 4 parametrics. I think they're due for a polar. But you can see, I think the first question is going to be about, let's see here, is going to be area, okay? The second question, it could be rate of change, all right? But don't be afraid of it, guys. Don't be afraid of it. This is all doable, very easy to do. And if you fine-tune your focus, I think you guys will be all right. Hopefully this helps, guys, and I'll be praying for you guys that you guys get your 5. I'll see you guys on the next one.